All right, gang, we are going to do some more story problems. These are a little tougher than the ones we did last week, and they're a little tougher than the ones you did last year. The main thing I'm going to advise you with is being very neat, very organized, and writing your thinking out. We're going to start with a fairly simple problem, and then as we go through these 4 examples, they will get consistently more difficult. So stay with me. Every problem is a little bit different. The good news is on your assignment, you will get 4 problems that are just like these 4 problems, so that hopefully that'll help you work through them. They're even in the same order. So let's go ahead and take a look at number 1. It says find the value of 2 numbers if their sum is 23 and their difference is 5. Okay, so the 2 pieces of information that we need, we know there's 2 numbers, their sum is 23, their difference is 5. So we need to assign variables. For this, I'm just going to use a boring old x and y. So I'm going to say that x is the first number, and I'm going to say y is the second number. They're just 2 numbers. Okay, so it says the sum is 23. Sum means we're adding them. That means x plus y is 23. Their difference is 5 means that you're going to subtract them. X minus y equals 5. So the way that I've set this up, the x must be the larger number. So next to the first number, you could also put that it's the larger number, because when I subtracted them, I got 5. It doesn't really matter because we just used 2 arbitrary variables. All right, so we can solve this using elimination pretty easily because I already have a plus y and a minus y, so we can kill that, get rid of it. We add x plus x, which is 2x, add 23 and 5, we get 28. And then we divide by 2, we get x equals 14. So that's the larger number. So we know that one of our numbers is 14. So to find the other one, we can just put 14 into one of the equations. So I'll just use that top equation, put 14 in for x. So 14 plus y is 23. So if we're solving for y, we would subtract 14 from both sides, and we end up with 9 as our second number. So our 2 numbers are 14 and 9. Pretty straightforward on that one. Okay, I'm going to zoom out to get the whole next question on my screen here. So on number 2, it says, going down the river, a boat went 19 miles per hour. Going up the river, it only went 7 miles per hour. Find the current and the speed of the boat if there were no current. So I like to draw a picture with these. So I'm going to draw the river. And let's say that the river is flowing that way. So if the boat is also traveling that direction, that would be going up, or I'm sorry, that would be going down the river, downriver. And so the speed of the boat and the speed of the current are going to work together. If we then switch it, so I'm going to draw another little picture, and I'm still going to say the river is going this way, but let's say that the boat this time is going against the current. It's going the opposite way. That's going upriver, and the current will actually work against it. So I'm going to use letters that represent things. So we know that going down the river, the boat went 19 miles per hour. Going up the river, it only went 7 miles per hour. And we're finding the current speed and then the speed of the boat if there were no current. So basically you're figuring out how fast the boat would be going on still water and how fast the current's going by itself. So I'm going to use B as the speed of the boat, and I'm going to use C as the speed of the current. That's just the river by itself. So when we're going downriver, the boat and the current are working together, going the same direction. With that situation, you would have B plus C. If I'm going upriver and I'm going against the current, that would be the boat minus the current. And so that just kind of gives you an idea. Let me zoom in a little bit because I realized you probably can't see. So when the boat is going with the current, you add the boat and the current together. When the boat's going upriver against the current, you subtract the boat and the current. So when you're going down the river, the boat went 19 miles per hour. That would be B plus C is 19. The boat and the current are working together. You add those speeds together. When it's going against the current, it's going upstream, upriver. You take the speed of the boat and you're going to subtract the current because the current's going the other way. It's going to slow it down, and that's why it's only 7 for this. And then we're going to try to figure out what the speed of the boat would be if it were on still water, and then what the speed of the current is. So if you look, we've got opposites here. We can go ahead and add those together and eliminate the current to start with. So B plus B is 2B. 19 plus 7 is 26. So if you divide those by 2, you'll find that the boat was going 13 miles per hour if it were going by itself. If there were no current and it was still water, that's how fast the boat would be going. Then we can figure out the current just by putting that back into one of these equations. So I'll just take the top equation. So I'm going to put 13 in for B, plus the current was 19. So if we just take that 13 off, we find out that the current is 6, and that would be miles per hour. And so the boat is going 13 miles per hour. The current is going 6 miles per hour. And since I labeled those with C and B and I wrote all this up here, going too crazy about writing out the answer is not absolutely necessary. If I did not write all that information out, then I would need to go, okay, the boat was going 13 miles per hour and the current was going 6 miles per hour. Somewhere in here we need to be labeling it so we know what the numbers represent. And in theory it would be good to write out sentences, but there's not a lot of space on these worksheets, so as long as we have it labeled somewhere and you have the miles per hour on your answer, we're going to call it good. Okay, so let's go down to number 3. I'm going to zoom it out to read it, and then I'll try to remember to zoom it back in for the next part. So it says, a plane traveled 480 miles to Seattle and back. So that's 480 miles to Seattle, 480 miles back from Seattle. That confused me the first time I read this, and I was looking at the answers, and it has to be, that's just the one-way distance. The trip there was with the wind. So this is kind of like the boat problem. You're traveling the same direction as the wind. That's going to speed you up. It took 6 hours. The trip back was into the wind. The trip back took 12 hours. What is the speed of the plane in still air? What is the speed of the wind? So this is a lot like our current problem, except they didn't really give us the speeds. They gave us the distance and the time, but that's okay. We can figure it out. So let's underline our important information. So it's 480 miles one way. That's the distance that we're going. With the wind, it took 6 hours. So I'm just going to underline with the wind, it took 6 hours. The trip back was into the wind, took 12 hours. And then it wants to know, what is the speed of the plane in still air, and what is the speed of the wind? So the first thing we've got to do is do some variables. So let's say that P is the speed of the plane, and that would be if it were still air. So we're going to figure out what the speed of the plane would be if there wasn't any wind working with it or against it. And then we're going to use W for the speed of the wind. So if you are going with the wind is going to work with you, and you would add the P and the W together, and you would get some speed. The problem is we don't know what that speed is. So we're going to have to work that out using the distance and the time here in a second. And if we are going into the wind, which you could also call against the wind, then you would have to subtract the wind from the plane, and there's going to be some speed to go in there. So what makes this problem a little bit harder is that we don't know what the speed actually is, but we do know the distance and the time. So we know the trip to Seattle was 480 miles, and we know if we look up here that took 6 hours. So we're going to take that and divide by 6 hours. And if I take 480 divided by 6, that gives me 80. So it's 80 miles per hour when you were with the wind, and so we'll use 80 for that with the wind speed. Okay, on the way back we went 480 miles again, but this time it took 12 hours. It took longer because we're going into the wind. So if I take 480 miles and divide by 12 hours, that is 40 miles per hour, and we're going to put 40 right there. And so now we have our two equations, and we actually do have opposites, plus W minus W. So the nice thing here is we don't have to multiply anything. We can just go ahead and put those two equations together and cancel it out. So the P and the P, two planes, added together, 80 and 40, make 120. And so we can solve for the speed of the plane. Divide by 2, so the plane's speed was 60 miles per hour. So if you put the miles per hour on there and you've got it written out to the side that that's the speed of the plane, we can just call that good. And then we can go back and figure out the speed of the wind by using one of our equations. Let's just use that top equation that was P plus W equals 80. We can put in the plane's speed, which we know now is 60, and we can quickly work out what the wind would have to be. Wouldn't even necessarily have to subtract that. I just know 60 plus 20 be the other. So the wind would have to be 20 miles per hour. So the hard part about this one is they didn't tell us what the overall speed was with the trip there and the trip back, like they did with the current problems. We had to actually work out those speeds using the distance and the times that they gave us. But that's the only extra step, and you guys have done distance and time problems before to get speed, so it shouldn't be too bad. I think the most confusing problem of all is number 4. So let's take some time with that one. I'm going to tilt this so that the last problem's not in our way. And this is a digit problem. It says the sum of the digits of a certain 2-digit number is 16. So let's just talk about that first sentence for a second. So if I have a 2-digit number, that means it's going to have 2 numbers. We don't know what they are, so I'm just going to call them X and Y. This would be the tens place, and this would be the ones place. If we had a 2-digit number, you'd have a tens and a ones. So we're going to say X is our tens digit, and Y is our ones digit. And we know that the sum of the digits for that number is 16. So if I took the tens place X and added it to the ones place Y, I would get 16. Now here's where it gets tricky. Reversing its digits increases the number by 18. And then it wants to know what is the number. So really you kind of have to underline this whole problem. It's not too long. So in order to reverse the digits, we have to talk a little bit about what the value of the number would be before we reverse them. So I'm going to zoom in a little bit so you can see what I'm doing. And I'm going to work over here to the side, kind of explaining what's happening. Actually, I may want that on the screen too. So X is our tens place and Y is our ones place. So if we're talking about the original value of the number, the tens place is worth 10, so that would be 10 times whatever that digit is in the tens place. So if it's a 2, it makes it 20, to 5, it makes it 50. You have to take it times 10. And then the ones place is just worth 1, so I could put 1y or I could just put y. And we don't know what the value of the number is. We don't know what the number is. So we're just going to keep it as 10x plus 1y for a second. Now, if they reversed the digits and we were trying to find the value, then I would make the tens place only worth 1 and the ones place worth 10. And they still don't tell us what the value is, but basically they're just switching the x and the y. But they do tell us that reversing its digits increases the number by 18. So I know that when I reversed it, that this number is bigger. And so what we could do is we could work this out. If I take this bigger number, 1x plus 10y, and I subtract from it the original number, 10x plus 1y, then I know that that answer is 18. And so I would have to work this out a little bit. You'd want to distribute, or I guess you could just subtract them. You could do 1x minus 10x and just do that in your head to be minus 9x. And then we could take 10y minus 1y, which would give us positive 9y, and that equals 18. So what this does is this gives us another equation that we could put up here, and it is a lot of work, but the process will be exactly the same every time. They're going to give you, what the difference is when they reverse it, and you'll have to subtract and figure out what that difference is and set it up that way. So it is difficult to understand, but I will tell you this process is the same for each of these problems, so that helps a little bit. Okay, so on this one, I can't just cancel anything out. I've got to change one of the equations. And so I see lots of 9s down here. I've got a negative. I just take that top equation, all times 9, and then rewrite it down here. That'll work. So I'm going to make that 9x plus 9y, and then 9 times 16 is 144. And I don't normally do this. I usually rewrite everything, but I don't have a whole lot of room, so I'm just going to leave this equation and multiply that one by 9, and I'm just going to use these two. So the negative 9x and the 9x cancel. 9y and 9y make 18y. 18 and 144 make 162. Divide by 18, divide by 18, we get y equals 9. So that's one of my digits. And then I can figure out what the other digit is by using the x plus y equals 16 would be the easiest one. So I know that x plus 9 is 16, and you can subtract 9 and get x equals 7. Now, when we do the answer to this problem, we need to remember it is a 2-digit number, and we had x first and y second. So since x is 7, that's my tens place, and 9 is my ones, is the 79. So 79 is the number we're looking for. We've got to go back and put that back into what our original problem was, and that's the original number. Okay, so that is the end of our examples.